everyone. So in today's video, we're going to be talking about dilutions, which is similarly related to concentration. Now, when we're talking about dilutions, we're really talking about decreasing the final concentration of your solution. Now, you probably do this all the time without really realizing it. Let's say you're making hot chocolate, you take a sip of it and you find it's too sweet. You add more milk, decreasing the chocolate concentration. Or if you are trying to make a soup and you taste the soup and it's too salty, you add more water to decrease the salt concentration. So the key thing about dilutions is really to decrease the concentration of whatever solution you have. So before we talk about how to calculate your dilution, we just want to do a little bit of a recap of what concentration is. Now, the definition of concentration is the amount of solute you have in a total amount of solution. So if I were to have a beaker of water, so I have a beaker of water, the amount of salt that I add into the water and stir it turns this into a saltwater mixture. Now my concentration would be based on how much salt I had. So let's say I added 3 grams of salt, and what my total volume of my mixture, so let's say I had not 3 liters, let's say I had, let's make it easy, 2 liters of water. So my concentration of salt would be 3 grams of salt for my 2 liters of water, which would give me a salt water concentration of 1.5 grams per liter. So whenever we're looking at concentration, we're really looking at the ratio of how much solute I have for my given solution. And again, my solute is the thing that is being dissolved, and my solution is the thing that does the dissolving. So that my equation for concentration is really the amount of solute that I have divided by my total amount of solution. Now, dilution is a little bit different than that. When I'm looking at dilution, I'm looking at how much I'm decreasing my total concentration by increasing my solution. Now, the equation for dilution is actually quite simple. C1 times V1 equals C2 times V2, where C1 and V1 are my initial concentration and volumes, and C2, V2 are my final or diluted concentration and volume. Now, the key thing is that my concentration is measured in grams per liter, both my initial and final concentration. The unit is grams per liter, and my volume, my unit for both would be liters. Now, you might notice that there is no massive solute in this because when I am diluting, I am not changing the amount of solute that I have. I am just increasing my total amount of solution. So the amount of solute actually never changes in my dilution. I am just increasing my total solution. So with that being said, right, my initial concentration is going to be higher than my final concentration, and my initial volume is going to be lower than my final volume, because to dilute, I'm adding more solvent to increase my total volume of my solution. So what we're going to do is we're actually going to do 3 practice questions to work on this equation. So if we're looking at our first question, you have 2 liters, so I'm going to highlight the 2 liters, of a 10 gram per liter solution. You add enough water for the volume to become 5 liters. What is the new concentration? So what we need to do is we need to write down what we have. We have C1, which is our initial concentration of 10 grams per liter. We have V1, which is our initial volume of 2 liters. And it's basically said right here. So this is our initials. Now, it says you add enough water for the volume to become 5 liters. So this is our V2, 5 liters. We do not know what our C2 is, so that's why I have a question mark. So our equation is going to become C1 times V1 equals C2 times V2. So 10 grams per liter times 2 liters equals C2 times 5 liters. So basically, to isolate C2 by itself, I need to bring this 5 liters onto the other side. So that means I'm dividing this by 5 liters. So if I'm looking at it mathematically, I'm doing 10 grams per liter times 2 liters divided by 5 liters. So I get C2 is equal to 4 grams per liter, which actually makes sense because when I am diluting a solution, my concentration goes down because my total volume goes up, which is what I see right here. So we're going to do 2 more questions to practice this equation. Okay, question number 2. You have 2.5 liters of a 20 gram per liter solution. What will the final volume be if you add enough water to dilute the concentration to 5 grams per liter? Okay, so I've highlighted my variables. Now I need to list them. So C1 is 20 grams per liter. V1 is 0.25 liters. C2, which is my diluted concentration, is 5 grams per liter. And I do not know what V2 is, so it's question mark. Equation C1 V1 equal C2 V2. 20 grams per liter times 0.25 liters equals 5 grams per liter times V2. Just like before, we need to bring our C2 to the other end. So bring this over, and if I bring this over, this turns into a division. So to find V2, I need to do 20 grams per liter times 0.25 liters divided by 5 grams per liter, and I get V2 equal to 1 liter. Okay, let's try our last question. Our last question is the following. How much of a 2.5 gram per liter solution do you need so that your solution obtains a concentration of 1.2 grams per liter and your total volume is 6 liters? So this one's actually a little bit different. I don't actually have my initial concentration and initial volume. I only have my initial concentration, C1, which is 2.5 grams per liter. I don't have V1, but I know that my final concentration becomes 1.2 grams per liter, and my final volume becomes 6 liters. So I'm still doing C1 V1, equals C2V2. So I have 2.5 grams per liter times my unknown volume, V1, but that is going to give me C2, which is 1.2 grams per liter, times V2, which is my 6 liters. So I'm actually bringing this to the other side of the equation. So to find V1, I need to do 1.2 grams per liter times 6 liters divided by 2.5 grams per liter. So when I do that calculation, I get an answer of V1 equals to 2.88 liters. I hope this helps, and I hope that you have a great day.